Hello everyone, Miss Hanley here. These are notes number 8, which you don't actually have a notes page for this particular topic. So we're just going to use the actual worksheet that is the assignment to discuss a little bit of what you'll be doing. So if you do not have a copy of that worksheet in front of you, please stop this video and go print it or get a hard copy from Miss Hanley so that you can fill it in as we go through this video. Okay, so just to read through directions, this is putting all of the systems of equations solving into one group, and now it's up to you to decide what's the best way to solve the system. It might be that you want to use substitution, you might want to use elimination, you might want to graph, and you will get the same answer no matter which method you choose. However, there's usually one, sometimes two methods that will be a lot simpler depending on the type of equation you're given. So we want to be able to identify that and work with that, and all the practice that you did with linear equations earlier will be helpful here. So for each problem below, we want to decide which method of solving would work best for the type of equations given. We can choose from graphing, substitution, or elimination, as we just said. We want to write the number of the problem in the corresponding solution column and give a brief explanation of why you chose that method. So here are our three columns. Now let's go and actually look at the questions and see if we can categorize which one is which. All right. So for the first one here, 2x minus y is equal to 8. X plus y is equal to 4. So before I tell you what I would use, I want you to pause the video and think about, with those two equations both being in standard form, which method you think would work easiest here. And once you've decided that, come back to the video and we'll explain. The method that I think would be easiest in this first one is going to be elimination, and that's because they are already set up in standard form, and if I add these two lines together right now, y and negative y are going to cancel each other out. So when we do elimination, we want things to be lined up, we want them to be in standard form, and if they're already starting out that way, that's going to be an easy method for us. If you chose substitution here, then you're also probably on the right track, because these equations, both of them, are really easy to solve for a variable. If I want to solve x plus y equals 4 for x, all I have to do is take away y from both sides and substitute that in. I still think elimination would be the simpler choice here, so in number 1, I would put that in the elimination category up above. And I'm just going to put an E right next to it for right now. And up above, when you put your choice, you also want to tell me why you chose that. So if you chose elimination here, my reasoning would be because both equations are in standard form, and it's easy to cancel a variable. So let's look at a couple other ones, and then I'll let you guys do this practice yourself and see if you can identify what would be simplest. I'm going to jump down to number 6. Alright, so I see y equals 3 minus x and 5x plus 3y equals negative 1. These are not in standard form, so we can't really use that same logic that we just had. But I noticed that one says y equals. This first equation says y equals. So when we are thinking about solving a system, if you have one equation that's already solved for a variable, like y equals, that would be a good indicator that I want to use substitution, right? Because substitution is when you can substitute in this 3 minus x into the y spot of the second equation. And that would be a pretty simple process here. If you were not so strong with substitution, this would also not be too difficult to actually graph, right? And usually people stay away from graphing just because it takes a little bit longer, but if you notice that you could just solve 5x plus 3y equals -1 for y, it wouldn't be too difficult to graph. I still think substitution would be the stronger choice here. All right, and we'll do one more together. So the third one I want to look at is number 8. All right. And so number 8, there are two clear options for me. The first, if we're doing it algebraically, would be substitution because I have both equations solved for a variable, right? So we could take that 3x minus 1 and substitute it right in for y in that second equation. And so you get an equation with only x's. Well, that's pretty easy to solve. But on the other hand, excuse me, they're both in slope-intercept form. So that would be really easy to graph. So for number 8, you could make the case for substitution or for graphing. I think both are equally as simple. And feel free to put number 8 in both columns up above, both the graphing and substitution. Or you can pick whichever one you think you would use the most. So some of these equations get a little bit tricky in the way that they're reworked, but remember, no matter which method you pick, you're getting the same answer. So there really isn't a wrong answer here, but you want to make life as easy as possible for yourself. All right, so take a couple minutes, pause the video, go through and categorize all of your equations, and then when you're ready, you can flip that paper over and we'll... Okay, so you've now decided what method you're going to use to solve all of these systems, and let's do a few together where we're actually going to solve them. So we'll do number 1. On the back side, we said that we were going to use elimination for number 1, and I already have my equations lined up. That's why we chose elimination. We want to remember, look at our variables. So I'm going to cancel y because they have the same coefficient of 1 and they already have opposite sides. So there is no multiplying that I have to do here. So all you need to do is take your two lines, and add them together. So we have 2x plus x, which is not 2x squared, that's going to be 3x. And then negative y plus y cancels, 8 and 4 is 12. And so if you divide by 3, we find out that x is equal to 4. Remember, we always have to find both x and y, so I would then take that answer and substitute y is equal to 4, and then take away 4 from both sides, and so y is equal to 0. Sorry, that got a little squished there. So the point 4, 0 is the solution to this system. Okay, so next let's look at 6, where we said substitution was going to be our best bet here. So we want to take what y is equal to and substitute that into our second equation. So right here, we're going to take I'll make this a little bigger here. There we go. We're going to take what y is equal to, which is 3 minus x, and that entire piece right there is going to get substituted in for the y spot in our second equation. So my new equation will read 5x plus 3 times 3 minus x, and this is where the y value originally was. Now it's 3 minus x. That's equal to -1. What you want is to only have an equation that has one variable, and now we have that. So let's keep simplifying. We can distribute there. So 5x plus 9 minus 3x is equal to a -1. 5x minus 3x, they're on the same side, so just combine them. So 2x plus 9 equals -1. Take away 9, so 2x is equal to -10. or x is equal to -5. Again, don't forget you always need to find that second value. So over here, I'm going to substitute what we got for x into that first equation. You can choose either equation. The first one looks simpler to me, less actual calculations happening. So we have 3 minus, and be careful when you substitute in the x value because it's minus x, but our x is a -5. So you have really 3 plus 5, or 8. So the solution to your system is the point -5, 8. Okay, and so for this final one, we're going to look at how to solve number 8 by substitution here. You could certainly choose graphing. I just don't have a nice clean graph to use, but that is obviously a choice if you would rather. So let's look at number 8, where we have y equals 3x minus 1, and we said we had two options, substitution or elimination. Second equation, y equals 2x minus 5. One equation is solved for a variable, so we're going to go ahead and substitute the 3x minus 1, what y is equal to, into the y spot of the second equation. So this is what my equation will look like. Instead of y equals, we'll have 3x minus 1 equals, and then the other side will be 2x minus 5. So from here, I need to combine my variables, so take away 2x. So we have x minus 1 equals -5. Add 1, so x equals -4. And then don't forget, we always have to find that second value. So we'll say y equals 3 times -4 just by substituting. Minus 1, so we have -12 minus 1, or -13. So you get the point -4, -13 as the solution to your system for number 8. So take some time and solve the rest of these. You can choose any method, like I said, and refer to the work that you did on the front side so you know which one to choose.